Hello, welcome. This video is on graphing nonlinear functions. Nonlinear means it's not a line. So it's some kind of curve. We're going to talk about different techniques for graphing in this video. I try to use a calculator a lot, so you should try to have a decent calculator. At the time of making this video, I kind of like the Casio FX991EX, but there's plenty of good calculators. All right, let's talk about probably the most basic nonlinear function, and that's the parabola. F of x equals x squared. Let's just go right into it and start graphing. So you should make an x and y axis. I already have that on the graph on our slide here. X is left and right, y is up and down. Where the two axes intersect, that's the origin. All right, so hopefully you know a little bit about how to plot points. Okay, so what we want to do is we want to find the highest or lowest point by considering the domain and range. This point is called the vertex. So looking at our graph, the function x squared, the domain means what numbers can we choose for x? Well, we could choose anything we want for x. There's no restrictions on the domain. Now the range, well, let's think about what numbers we could get for f of x, or the y value. When any number is squared, on the right-hand side we have x squared. So any number that's squared, what's going to happen to any number that's squared? Right, it becomes positive. So the smallest number you could get is 0, and that's when x is 0. Okay, so the domain is all real numbers. We talked about that. This means we could choose any values for x. The range is from 0 to infinity. The smallest value we can obtain for y is 0, and this is when x equals 0. So when x equals 0, the graph will have a point at the lowest point of our graph. That's going to be called the vertex. Okay, so we're going to make a table, and we want to choose that value that is going to give us the highest or lowest point. In this case, it's 0. Then what we're going to do is we're going to pick the values that give us the highest or lowest point on the graph. Okay, we talked about that. Then choose two numbers for x on the left and the right. So two numbers to the left of 0, and then two numbers to the right of 0. So 0 we put on our table, and then what's to the left of 0? Well, there's -1 and -2. Try to put it in order here. And then +1 and +2. Okay, now you could either plug those into the function and do it by hand, or you could use your calculator to plug those in. You could do it in your head, it's up to you. So here's our y values. So for 0 we get 0, and for -1 we get 1, because -1 squared is 1 and -2 squared is 4, right? -2 times another -2. And then when we plug in 1 and 2, well, 1 squared is 1 and 2 squared is 4. So now we could plot those points on your graph. There we go, there's our 5 points. So for a parabola, we like to usually pick 5 points. That's a good number of points. And then try to sketch it. It looks like some kind of a U shape. And we're all done. So again, what was important is that we pick the number that gives us the smallest or the highest number. In this case, it's 0. And then we pick two numbers to the left and two numbers to the right. We're going to do our next example, and we're going to talk about a vertical translation. Vertical translation means a graph is translated or moved vertically. Vertically is up or down. So if we have a function of the form f of x equals x squared plus k, notice that it has that x squared just like in our last example, but then we have a number after the plus sign, which is k. Whatever that number is, it moves it up if k is positive, or down if k is negative. So the last graph we had, kind of recall what it was. It would look like a U shape called parabola. So this example, f of x equals x squared minus 3, it's going to be the same graph, but moved. Now it's a minus 3 after the x squared, so is it going to go up 3 units or down 3 units? Right, down 3 units. All right, so here I have a graph already made. You could always go to Google Images or something like that and get those. On my website, I have some graph paper that you could print up also. Or if you have a tablet, if you have some kind of a pad that has graph paper, that's always great too. If not, you could just make your own X and Y axis. All right, we're still going to pick points. So now again, our domain, all real numbers. Our range, well, this time it's dropped by 3 units. So therefore, our range is from -3 to infinity. Now when we pick points, we're still going to pick 0. So just a side note here, I like to still pick numbers all the time. You can get a general idea of what the graph looks like, but sometimes you just want to know what are those exact points. You could use your calculator to get the values, or you could do it by hand, but that's what we're doing here. We're going to actually still do it kind of the old-fashioned way, plug in some numbers, but plug in the correct numbers to see what the coordinates will be. So the lowest point will still be when x is 0. So again, the same thing. Now it's not always going to be 0 that we start with, but we'll get to that in the next example. So again, 0 in the middle, 2 to the left, 2 to the right. And then plug each of those in to the function, work it out. Remember to pause the video and work it out. Come back when you're ready. All right, so let's plug in those numbers. So like if you plug in 0, 0 squared is 0, and then 0 minus 3 will be -3. If you plug in -2, -2 squared is 4, and then 4 minus 3 is 1. -1, if you plug in -1, -1 squared is 1, 1 minus 3 is -2. And same thing with the next two. Plug in 1, 1 squared is 1, 1 minus 3 is -2. And 2, 2 squared is 4, 4 minus 3 is 1. All right, plot those points. Pause the video. Okay, there's our points. And now draw that U shape connecting those dots. There you go. Okay, for our next example, we're going to discuss horizontal translations. So this is when a graph is moved left or right. Now we've been talking about f of x equals x squared, which is a basic parabola, but this applies to other functions as well. It's called the parent graph. Okay, so if we have x minus h squared, then it's moved to the left h units if h is negative, or to the right h units if h is positive. I know it gets kind of confusing. What I like to think about is getting a 0 inside the parentheses as a result. Whatever number, when you replace x with it, results in giving you a 0 inside the parentheses, that's the direction it will be moved. Okay, so looking at example 3, what number could we replace x with that would give us a 0 inside the parentheses? So what number minus 3 is 0? Right, 3. That means it's going to be moved 3 units, and 3 is positive, to the right. Okay, so let's first look at the domain. The domain is all real numbers. And the range, well, that's still going to be 0 to infinity. Whatever we get inside the parentheses, once you square it, it's still going to be positive. Actually, the smallest number could be a 0, which is neither positive nor negative. So therefore, our range is 0 to infinity. Okay. I wrote some notes here, so make sure you take your time to read it. We talked about that h is 3. So looking at the pattern x minus h, our h is 3. Or you could think of it as it's 3 because 3 minus 3 is 0. So that means it's going to have the same shape as x squared, that U shape, but every point will be moved to the right 3 units. So you could either think about all the points on our first graph, called the parent graph, and then every point move it over 3 units. Okay, so that's one method. Again, personally, I like to pick my points, plug it into the function to get the actual y results by hand, or using a calculator, and then plot those points and graph it. But we needed to know what number will give us a 0 inside the parentheses, and that number was 3. Okay, hopefully you're following along. So 3 is a number that makes it 0 inside the parentheses. Now we're going to do the same thing we did before. Choose 2 numbers to the left of 3 and 2 numbers to the right of 3. So I put 3 in the middle. What's to the left of 3? Right, 2 and 1. What's to the right of 3? 4 and 5. So those are the numbers you're going to plug into your calculator, work it out. You could either do it by hand. Some calculators, you could actually get the whole table for it. Don't have to do anything. You can let the calculator do the work for you. All right, so plug it in, get the y values. Those are the answers. Again, pause the video, work it out. And then you could plot those points and draw in your shape. All right, here's our next number. This one has a horizontal translation and a vertical translation. So for the horizontal translation, what number plus 3 gives you 0? Right, -3. So this graph is moved 3 units to the left, and then the -2 on the outside, that number moves it up or down. Right, it's going to be moved down 2 units. Okay, so what we're going to do is we're going to start with the x value of the vertex. So what number will give us 0 inside the parentheses? And that was -3. So now on your table, put -3 in the middle. And then what is to the left? We want 2 numbers to the left, 2 to the left, 2 to the right. So what's to the left of -3? -4, -5. And then what's to the right of -3? -2, -1. So those are the x values of the coordinates that we want to get. Plug those in or use your calculator. Remember, a lot of calculators will do it for you. All right, so there you go. Those are our y values. Now we need to plot those points. So there's our points, and then sketch it. That's it. All right, so the important thing is our starting number, which was -3. So that goes right in the middle of our table, then 2 to the left, 2 to the right. I do have a video on how to use a Casio calculator. I'm going to have that in the link. All right, let's do another one. So here's our next one. This one's a little bit different, right? Why is it different? It's got that negative in front of the x squared. There are no parentheses. That means it's not moved anywhere left or right, but it is moved up 2 units. Now, what do you think that negative does? Yeah, what it does is it flips it upside down. Now, if you don't know that, it's okay. We're still going to start with our table. We're going to pick the number that'll make it 0 before you square it. So if there's no parentheses, our starting number is always 0. Find the x value of the vertex. Since there are no parentheses, it will be 0. So if there's parentheses, we're going to pick the number that'll make it 0. Otherwise, we're going to pick 0. Now the negative, think about a parabola that's upside down. We're not going to have a we're not going to have a minimum. It's going to be a maximum this time. So if this parabola is going down, then there's the highest point of the vertex. That's called the maximum. So for parabolas going up, it's a minimum. For parabolas going down, it's a maximum. All right, so we're going to make our table. We're going to start with 0, 2 to the left, 2 to the right. So 0 in the middle, 2 to the left, -1, -2, 2 to the right. Plug them in. Now keep in mind that the square only applies to the x. So if you're plugging them into your calculator one at a time, you got to square the number and then make it negative or use the negative in front. Then add 2. Okay, like for instance, plugging in -2. If you plug in -2, let me go ahead and write it up here above the graph. Oops, sorry. So let's say we're going to work that out. We have to work out, so notice I used parentheses. I replaced the x with -2, but I had to put in parentheses. So -2 squared is 4, but then we still have a negative in front. So that's still -4 plus 2, and that equals -2. So if some people get confused with all these negatives. All right. Again, many functions you could just type in the function f of x equals -x squared plus 2 and have it start at -2 and end at 2 and use a step of 1. and then the calculator does it for you. All right, plot your points, and then sketch it so you can see it. The U shape is flipped upside down. Okay, so those examples we did were strictly for a parabola. But in general, the exponent could be any number. So that's what this is, a times x minus h to the power n plus k. We're still going to set up a table of ordered pairs. And when choosing values for x, we always start with h. So we always pick the number that makes it 0 inside the parentheses. And then we pick two numbers to the left and two numbers to the right. So we're trying to keep our directions as basic as possible here. Then we're going to plot the points and try to draw a smooth curve. So it's not always going to look like a parabola. We have some different shapes coming up. All right. This is called a cubic function. F of x equals x cubed. So here's example 6. Do we have any parentheses? No. So in that case, we're going to start with 0. And then we're going to pick two numbers to the left, two numbers to the right. So put 0 in the middle, 2 to the left, 2 to the right. All right, now get the y values. Pause the video. Get those numbers. All right, so you should have these numbers, -8, -1, 0, 1, and 8. So like when you plug in -2 to the third power will be -8 because it's -2 times -2 times -2, so forth. All right, plot the points. And I said it looks like a stretched out S shape. I don't know. Not really an S. Kind of an S, but backwards and then flipped. Yeah, maybe that's a bad description, but you get the idea. It's that kind of like curve. So not a parabola. You can see on the right hand side it goes up like a parabola, but on the left side it kind of curves down. That point 0, 0, it's actually, there's a name for it. It's actually called the inflection point, where the curve changes direction. That's one way to explain it. All right, but anyways, plot the points and always try to draw a smooth curve. It doesn't have to be perfect. If we want perfect, then we want you to do it on a computer. This is a pretty, good estimate. All right, here's our next problem. All right, hey, this one has parentheses, right? So we're going to start with h. Choose the number that would result with 0 inside the parentheses when replacing x. So what number minus 4 gives us 0? What number should it be to give us a 0 inside the parentheses? That's right, 4. So that's a number that we're going to put right in the middle. Then two numbers to the left and two numbers to the right. So 2 and 3. What's right after 4? Yeah, 5 and 6. Just think of a number line. All right, pause the video, work those out. All right, we got -7, 0, 1, 2, and 9. Plug those in. Graph those points. So 2, -7, and so forth. And yeah, it should give us like a S shape, but sideways and flipped, kind of stretched out. Again, this is called a cubic function. So this is what the shape of a cubic function looks like. All right, this is to the fourth power. Not really name, it's just to the fourth power. Are there any parentheses? No, no parentheses, right? So what do we start with when there's no parentheses? Yeah, you got it, 0. So we're going to start with 0, and then 2 to the left, 2 to the right. So what's to the left of 0? -1, -2. What's to the right of 0? 1 and 2. Plug them in, pause the video, work it out. All right, let's plot those points and sketch it. It actually has a parabola shape. Yeah, it kind of looks like a parabola. It's not a parabola. We don't want to use the word parabola, but it's like a parabola. Kind of looks like a parabola, right? Yeah, I know. But what is it not? It's not a parabola. All right, that's it. Let's go to the next slide here. This one is also to the fourth power. There are parentheses. So what number are we going to start with? The number that'll make it 0 inside the parentheses. Yeah, that's it, -3. So -3 plus 3 would be 0. What's next? 2 to the left, 2 to the right. So -4 and -5, -2, -1. All right, use your calculator to get those results. There we go, almost the same as the last one. Actually, it is the same values as the last problem. Plot your points. And it's that parabola shape, not a parabola. And you're all done. All right, here's our next type of function that we're going to talk about. This one has absolute values, so it's called an absolute value function. It's almost the same as the last problems that we were talking about. When we have the absolute value just makes whatever is inside, once we have a single number, it just changes it to a positive number. So the absolute value of -8 is +8. The absolute value of 11 is still 11. It just makes it positive. If it's already positive, it keeps it positive. All right, so this is called f of x equals the absolute value of x. That's our parent graph. And then the same thing's going to happen. It's either going to be moved left or right, or up and down, or both. So there are no numbers inside the absolute value other than x. So just like the ones with parentheses, if there's nothing inside the parentheses, we start with 0. If there's nothing inside the absolute value along with x, start with 0. And then I already put what it's going to look like. This one's going to look like a V. This one has a V shape. So start with 0. Same idea. 2 to the left, 2 to the right. Okay, so now absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So those are our coordinates. Plot them and draw your shape. right, this one's very similar to the last problem. What's different about it? Right, the negative. What do you think that negative will do? Yeah, good job. It's going to turn it around. It's going to flip it upside down. There are no numbers inside the parentheses. Sorry, not parentheses. There are no numbers inside the absolute value. So what are we going to start with? 0. 2 numbers to the left, 2 numbers to the right. So this time you plug them in, but whatever you get, it's going to become a negative because there's a negative outside the absolute value. All right, always make sure you pause this video and work through it. All right, plot your points. Graph it. There it is. There's our V shape, but upside down. All right, here's our next one, a little bit more interesting. This one does have a number inside the parentheses, inside the absolute value. We always try to get 0 inside the absolute value. Whatever number that is, that's the number we start with. So what number, when we replace x with it, will result with a 0 inside the absolute value? What number plus 2 equals 0? Right, -2. So that's a number we're going to start with. And then 2 to the left, 2 to the right. So -2 I have there in the middle. What's to the left? -3, -4. What's to the right? -1 and 0. All right, pause. All right, so you've plugged those into your calculator. What do you got? Right, lots of 1s and 0s. Plot those points and graph it. So the parent graph is the absolute value of x. This graph is the same graph, but it's moved over 2 units to the left and then 1 unit down. So I know it's a +2 inside, but the standard form was with a minus sign in the middle. So you got to think of it as there's a minus sign in the middle, but it turns into a plus, so that means our h has to be negative. Therefore, h was -2. And the number on the outside moves it up or down. In this case, it's -1, so it moved it down 1 unit. All right, hang in there. We're almost there. We're going to talk about the square root function. The first thing we're going to do is discuss the domain. We've talked about the domain of square root functions previously. Since it has a radical, inside the radical, it's called the radicand, it must be greater than or equal to 0, right? We cannot have the square root of a negative number. It's not a real number. For graphing, we're using real numbers. So whatever's inside the radicand, we always set it greater than or equal to 0. This is going to help us with what numbers to choose for x. Now we're going to set up a table of ordered pairs that satisfy the function. We're always going to start with h. So that's the number that makes it 0 inside the square root. Then, instead of saying 2 to the left and 2 to the right, I cannot say that in these problems. Because on one side, they're not going to be real numbers. So I just have to say, pick 2 or 3 more values that are in the domain. So 2 numbers, at least, that satisfy step 1, which what I mean is that they're in the domain. And try to be clever about it. Pick numbers that will give us an integer. You don't have to, but it avoids having to plot 1.4 or 1.7 or 2.3. That's all I'm saying. All right, and then plot your points and try to make a smooth curve. It should look like half of a parabola sideways. All right, here's our first graph. This is called the parent graph because there's nothing else outside the square root of x. Once we have a number inside the parentheses or a number outside, sorry, I said parentheses. Once we have a number inside the radicand or a number outside the square root, then that's no longer the parent function. All right, what number should we start with? Well, let's look at the domain. You set the radicand greater than or equal to 0. All right, so x, that's the radicand greater than or equal to 0. We don't need to get x by itself because that's all there is. So that's our domain. We can only pick numbers bigger than or equal to 0. So we're going to start with 0. And then we want to choose values for x in the domain and values that will give you perfect square roots. All right, so we got to pick numbers bigger than 0. Well, what numbers are bigger than 0? How about 1? 1 is bigger than 0. And is it a perfect square root? Yes, it is. Square root of 1 is 1. How about 2? 2 is bigger than 0. Is that a perfect square root? No, right? Square root of 2 is 1.4. Same thing with 3. 3 is bigger than 0, but it's not a perfect square root. How about 4? Yes, it's bigger than 0, and it's a perfect square root. What's the square root of 4? That's right, 2. All right, so we're going to pick 0. Square root of 0 is 0. 1, what's the square root of 1? 1. 4, what's the square root of 4? 2. How about one more? 9, right? Yeah, 9. 9's a good one. What's the square root of 9? 3. Now, you still could have used your calculator. If you set up a range on your calculator, you could just plug in 0 to 10 and then choose the coordinates that are the nicest to graph. All right, let's plot those points. And then make a sketch. There it is. Half of a parabola. So don't go past 0 to the left. You can't plug in -1 because square root of -1 is, well, you don't get a real number. It's actually I, but we're not using that right now. All right, let's go on to the next one. Oh, here we go. There's a number underneath the square root, +2. So, well, let's do our domain. We write the domain as x plus 2 greater than or equal to 0. Is x by itself? No. So let's go ahead and get x by itself. What do we do? -2 on both sides. And that's it. So now our domain is -2 to infinity, brackets at the -2. So we're going to set up some ordered pairs. Start with -2. This is where you kind of have to be clever. You have to pick numbers that are bigger than -2 and that would result with a perfect square root. So think about the perfect square roots. 1, 4, 9, 16. Those are the numbers we're trying to get. So what number plus 2 will equal 1? Right. -1. All right, we should probably do -2 first. So negative 2 plus 2 is 0, and the square root of 0 is 0. Then we said negative 1. Negative 1 plus 2 is 1, and the square root of 1 is 1. All right, we want to get a 4. What number plus 2 equals 4? Right, 2. So that's the next number we want to choose here for x, 2. 2 plus 2 is 4. Square root of 4 is 2. All right, the next number we want to get for y is 3. So square root of what number is 3? Right, square root of 9. So we want to get a 9. What number plus 2 is 9? Yeah, that's it, 7. So 7 plus 2 is 9. Square root of 9 is 3. I think that's plenty of points. You can keep going, but that's already 4. So for square root functions, 3 or 4 points is good enough for a square root function. Plot those points and then sketch the curve. All right, here's our last problem. This one has a few things going on. First, I see inside the radical, it's backwards. It's a minus x, 3 minus x. That means something, right? Oh, and there's a minus in front of the square root. That means something. Usually it means like we got to flip it, right? All right, let's start with our domain. So how do we find the domain? We set the inside greater than or equal to 0. All right, pause it, work that out. Okay, subtract 3 on both sides. Now we have a negative in front of the x. We've got to get rid of that negative, so divide both sides by negative 1. Don't forget that when you divide by a negative, what do you need to do to the inequality sign? Right, you got to flip it. So x is less than or equal to 3. So this is a little trickier. We're going to start with 3, but we're going to pick numbers less than 3. So notice that I put 3 on my table down towards the bottom, just so that I could put it in order. All right, so we want to pick numbers less than 3. We want to get a 1. Let's plug in 3 first. I guess don't get ahead of ourselves. Plug in 3. 3 minus 3 is 0. Square root of 0 is 0. Negative 0 is still 0. All right, the next number we want to get is a 1. 3 minus what number will equal 1? That's right, 2. So let's choose 2 for x. So plug that in. 3 minus 2 is 1. Square root of 1 is 1, but there's a negative in front, so it becomes negative 1. All right, the next number we want to get is 2. Square root of what number is 2? Right, 4. So we want to get a 4 inside. 3 minus what number is 4? That would be a negative 1. Now I know some people might be getting like, what the heck is this guy doing here? Where are these numbers coming from? If you're using your calculator and you wanted to do it for you, just know that we got to pick numbers that are less than 3. So when you choose your range on your calculator, choose about 10, 15 numbers if you want to. So your start could be negative 10, and then your end could be 3. That'll be about 13 numbers. So you could just choose numbers that are less than 3. So that's the important part. They have to be less than or equal to 3. You can't pick x equals 4 or x equals 5 because it'll give you an error. So you could keep playing around with your calculator if you're getting kind of confused on what numbers I'm choosing. I'm trying to choose numbers that give me a perfect square root. All right, so that's why I chose -1. So 3 minus -1 is 4. Square root of 4 is 2, but there's a negative in front, so that's why it's -2. All right, let's do one more. We want it to give us a 3 when we take the square root. Square root of what number is 3? 9. So I want a 9 inside the radical. So 3 minus what number will be 9? So it's got to be a negative, so it'll turn into a positive, so that'll be a -6. So plug in -6 into your calculator, put in -3 minus -6, and you'll see that you get -3. Anyways, I know that's kind of complicated, so just make sure you're picking values for x that are 3 and lower, 3 and less than 3. And then plot whichever points you could graph. If you get decimals, that's okay. Decimals happen. All right, plot your points. There it is. Oh, this one kind of goes the other direction and is the bottom half of this parabola sideways. There it is. Remember that it has to be less than 3, so that's why it goes from 3 and to the left. All right, that's it for this video. I know this last one was a little tricky. The square root functions are probably the trickiest of the bunch. So take your time with those. Don't forget about tutoring. I'll see you here for the next video. Have a good day.